Good afternoon, dear students. You are welcome for this lecture on AlgoSat today. And our subject today is the topic is from subject metrology, and we will be learning regarding units of measurements and standards of measurements, and also we will try to find out the difference and the terms like interchangeability, accuracy, and precision. So, we will be discussing units of measurement, standards of measurements, interchangeability, accuracy and precision, and reading of measurements on instruments. Whatever we are producing in this industrial age has to be measured, and what we measure, the results should be accurate and precise. They should be both accurate and precise. Accuracy is the value which is actual true value, and while precise is the term used for when you have same results with the measurements, there should not be any deviation from the reading. So, in engineering, metrology has been defined as science of measurements of length and angles, and as such other quantities in precision measurement which can be expressed in linear or angular units. So, in general, measurement of length is very important. We define many measurements with help of this length. Knowledge of metrology and its practice is ever increasing in the industry. The development in engineering production in the past has been inseparable from that of metrology. It is certain that the more exacting demands of the industry of mechanisms and assembly which meet stringent design requirements will result in even closer attention being paid to science of measurement. So, the writer Lord Kelvin comments, I often say that when you can measure what you are talking about and express it in numbers, you know something about it. But when you cannot measure it, when you cannot express it in numbers, your knowledge is meager and unsatisfactory kind. So, whatever designs we are having of different components, we have to express them in terms of measurements, and these measurements should be very accurate and precise as well. So, this statement of Kelvin comments presents a powerful case for subject of metrology to be part of studies required of an engineer. It is also important, it also points out the way to the fact that if we are to further improve the process of manufacture, we must continuously improve and develop our means of measurement. The basic purpose of measurement in engineering industry is to determine whether a component has been manufactured to the requirements of a specification. Usually an engineer from the engineering drawing, the measurement of length and angle is of utmost importance, which helps to explain certain geometrical quantities like roundness, squareness, flatness, etc. to a known system of tolerance. So, with this measurement of length alone, we are able to find out the geometrical rightness of the components in terms of roundness, squareness and flatness as well. And other important measurement is of the angle, which is in 2D we have the angle in radians, while in 3D geometry we have the angle represented by steradian. So, measurement is as old as history, but precise measurement is hardly century old. So, this is quite astonishing and surprising that first micrometer was produced in 1867, which is not more than 150 years from now. So, since the first practical micrometer that was produced in 1867, measurement of length has improved to several orders of magnitude. So nowadays we are calculating the measurement of length to a very detailed uh, aspect, and we are measuring the things in microns in the general production houses. Measurement is an essential part of the development of technology, and as technology becomes more complex, so the technique of measurement becomes more sophisticated. So we are having lot of sophisticated measuring instruments available in the market, in the industrial market, and the price of these instruments is quite high because they are doing a very special job. For example, a vernier caliper of 6 inches length may range at the rate of rupees 2000, and for a vernier caliper which is capable of measuring about 20 inches, maybe the price may be as high as 20,000, and this price is so high for a reason, of course, because the companies which are producing these measuring instruments, they are making them very accurate, and calibration of these instruments is done well because there is lot of dependence upon these measuring instruments in this sophisticated atmosphere of manufacturing. So metrology means the science of pure measurement, economics of measurement. So the measurement which we make for production should be economical. So we have to cover this aspect so that measurements are accurate and precise, and at the same time do not cost much. The economics of measurement has been greatly affected by increased variety of purposes of measurement. In the past, many engineers viewed instruments primarily as a means of sorting good and bad products. So when we make measurements in the industry for running production, for running components being made in the company, we are just sorting out whether the component is within the specification or not, and these specifications are written and explained in the detailed drawing of the component. So we are just making a decision whether the product is good or bad, that is whether it is to be rejected or it is to be accepted. So the production should be within some tolerance which is explained in the engineering drawing. Measurement is a comparative process. So we are just comparing the workpiece with help of the instrument. The basic purpose of measurement in engineering industry is to determine whether a component has been manufactured to requirements of drawing. For this purpose, we use either non-indicating equipment or indicating equipment. On your left hand side, you can see this job, and a ruler scale is placed over this job. So over here we have the indicating equipment in which we have some kind of ruler over here, and on your right hand side we have a go and no go gauge. I believe you all are familiar with go and no go gauge. So for a component to pass the test, it should go into the go side, while it should not enter into the not go side. So these are the two ways of making measurements. In one we are getting a numerical value. In the other one, the method is very quick for accepting or not accepting the component, and over here we do not have any numerical indication. So in this non-indicating type of equipment, we can see over here for an undersized component which enters into the go side as well as the not go side. So this component is to be rejected. And similarly, the other rejection is in this lower figure, in which the component is neither entering into the go side and nor it is entering into the not go side. So these gauges are made to certain tolerance so that we can find out whether the products have been made within the tolerance, specified tolerance or not. Measurement of length is the measurement of distance between 2 points in a straight line. So, whenever we are measuring length of something, actually we are just finding the distance between 2 points. It is of following two types. Number one, line measurement. It is distance between two lines or edges with instruments such as scale. So, we are just comparing those edges or those lines with help of a scale. We are not having end faces in this case. And second type of measurement is your end measurement. It is the distance between two surfaces or faces. So, in the second type, the instrument is touching the component from two sides, from two ends, and that is why it is called the end measurement. So, during making a measurement, the instrument is required to be very accurate and precise, but we also need to take care of procedure that we are following in making the measurements. For example, this parallax error is very common while making readings. Over here in the figure, you can see the workpiece is placed over here and a ruler is placed over it on the top face, and the correct angle from where we should take the reading is this one. It is representing the eye, which is having vision that is perpendicular to the face of the ruler or the face of the workpiece. So, if we are taking reading from this angle when the eye is over here, at that time the reading is not likely to be correct. It may be slightly increased value. So, this error can be somewhere near 0.5 mm. So, if we do not place our eye at the right position while taking readings, we are likely to have the parallax error. Similarly, if our eye is on the left hand side over here in this position, at this time the reading that we take for point M over here will be slightly lesser than the actual value. So, we are interested in making actual values. So, during measurement, error of parallax is important to get the right reading as shown in the figure. Another form of error is the cosine error. We can see over here the required edge, the edge for which we have to take the measurement is along this arrow, and the reading we are trying to take is between this face and the face on the back side of this edge. So, over here we can see that the scale is placed at some angle to this face where this B is written, this face B. The ruler is having, the scale is having some angle with this face, and that is why it will indicate a greater length for the job, and we should be aware of this kind of errors so that we do not take the wrong readings. Then let us discuss some terminology of measurement which we need to understand for using the instruments in a proper way. Number one is the indicated size. This is the size indicated by the scales of measuring instruments when measurement is taken. It makes no allowance for incorrect use of instrument such as application of excessive force. So, it is the indicated size is the size that the instrument is indicating for the component, but over here if we use excessive force, the instrument will not give the right reading. So, there is need for lot of care to be taken while using these sensitive instruments for getting the right value, that is the accurate value or the true value. So, reading value, this is the operator's interpretation of indicated size. So, whatever an operator indicates what he finds on the instrument's scale, he will tell that size, and that is called the reading value. Vernier scales are easily misread in bad light. So, digital readouts have lesser errors and are easier to use. So, uh, it is better to use or preferred to use the digital readout instruments because they give lesser error and they are also less strenuous. And then we discuss the measuring range. Whenever we are selecting and measuring instrument, we are selecting it for a particular range according to our requirement. This is the range of size between the largest and smallest dimension that can be read by measuring instrument. For example, the measuring range of 25 to 50 micrometer is 50 minus 25 is equal to 25 Then we discuss measuring accuracy. This is the accuracy of measurement expected from a measuring instrument. It can never be better than the indicated size. It is also called as tool accuracy and is defined as allowable deviation relative to indicated measurement. Hence, accuracy is trueness of value that an instrument indicates. Then we discuss accuracy of measurements. In any measurement, possibility of error is bound to arise. No measurement is exact, and the type of instruments used should be chosen to suit the accuracy of measurement required by drawing specifications. Although the measuring instrument may measure to given accuracy, the attainment of that accuracy will depend upon several factors. A vernier caliper may theoretically read to an accuracy of 0.02 but theoretically maybe theoretically, but it would be untrue to say that measurement taken with vernier caliper may be relied upon to 0.02 The degree of reliability would probably be in order of 0.04 that is double the least count. The quality of measuring instrument, that is the accuracy of scale graduations, etc., the temperature difference between workpiece and instrument, and human errors such as sense of feel, parallax errors, and errors due to misalignment of work and measuring instruments are all factors which may affect ultimate accuracy of the measurement. So, temperature is very important. As the temperature rises, the reading will be on the higher side. It is important not to emphasize the effect of any one of the possible sources of errors, but of capabilities of measuring instruments or methods. So, it is more important to use the instrument in a proper way to make the maximum use of the capabilities of the instrument. The ability to select a suitable procedure for determining a measurement accurately and economically is a basic skill of the metrologist. So, we must have the right feeling when we are trying to take a measurement. The instrument, the measuring instrument should have right contact over the component. So, this measurement is of two types which we have already discussed, that is the line measurement and the end measurement. In the line measurement, it is the distance between two lines or edges with the instruments such as scale. End measurement is the one in which the distance between two surfaces or faces is found out. So, in this figure we have measurement being taken over here by a scale. It has been butted with this piece over here, small piece, uh, which is in contact with this face, so that this scale butts over here on this end, so that we get a proper reading, so that the scale is placed on the right place on the left hand side, and on the right hand side we are taking the line measurement. So, this is a combination of end measurement and the line measurement, because it is having a contact over here on the left hand side, while it is not having any contact over here on the right hand side. And for taking measurements of different components, we use many instruments. Um, for these, the calipers is calipers are the one of the important and well known and common instruments used for taking any measurements. Over here we have fixed joint type of caliper. Number 1, this is for external diameter. We can create a gap over here which is made equal to the size of the component. So, this is for male measurements, and this one is the outside caliper, which is used for taking the dimensions of holes or gaps or slots. So, this measures the distance between two faces or the diameter of a hole. And this tool over here, which is called the odd leg caliper, is having a scriber over here, and there is a notch over here. This notch gets fixed upon the square edge of the workpiece, and while we pull this along the edge of the workpiece, this scriber marks a fine line on the job. And over here, this is the spring type of caliper, in which as we rotate this adjusting nut over here, this gap between the legs of the caliper is likely to increase. So, as we want to make a very fine adjustment, we will rotate this adjustment nut very slowly and with very little amount. Similarly, this one is for the internal dimensions, that is the outside caliper. The outside caliper is the one which is for internal dimensions, while so over here we should understand the construction and use of the calipers. We need to use them in a proper way. Over here we see that an outside caliper is being used, an inside caliper is being used on the engineer's tri-square. So, over here the upper arm is butted with the edge of the tri-square and the lower arm is giving the reading. So, these 2 points are in one line and they should not be twisted. Similarly, it is being shown over here on the right hand side how the caliper should be entered into the bore. So, it should be touching over here, and in this inclined fashion it should enter into the hole, and while we take the measurement we just raise to this position, and if the feel over here of the contact of the caliper is right, so that will be the measurement taken, and that will be compared with another instrument, for example a vernier caliper or a micrometer, to get the reading in digital form. Over here we have the spring type of caliper being used, the outside caliper, and we are just comparing the reading over here with the scale. So, with the scale itself, if the scale is quite accurate and the graduations done on or the markings done on the scale are quite accurate and fine, then we can make a measurement with help of this scale and outside caliper to the extent of accuracy of plus minus 0.2 mm. So, with naked eye or with this kind of instruments, we can still make a pretty good judgment about the size of the product. And over here is the outside caliper being used for measuring diameter of the job. Over here this caliper is moved from right hand side to the left hand side, and while these arms touch the job and get across the job, the right feeling will give the right feeling will be there when this touches and passes over here. We will get a feeling that yeah, it has touched. So this size, which is the gap between these calipers, can be measured on something else like the vernier caliper, and in this way we will get the measurement. So the feel over here should be right. So this we get with experience. Then we should be knowing well about the precision of the instrument. Precision of an instrument is the extent to which the instrument repeats its results when making repeat measurements on same unit of product. Hence, for precise instrument, the standard deviation is low. So a precise instrument will always repeat its readouts, the readings. And also it is important to know that an accurate, a precise instrument may not be an accurate instrument. And similarly, an accurate instrument may not be precise, but we need an instrument which is accurate as well as precise. So now we discuss general rules for accurate measurements. Number 1, measuring equipment should be between twice and 10 times as accurate as the dimension being measured. A vernier caliper may theoretically read to an accuracy of 0.02 mm, but it would be untrue to say that measurements taken with vernier caliper may be relied upon to 0.02 mm. The degree of reliability probably will be in an order of 0.04 mm. Secondly, accuracy is improved if the setting master being used for comparative measurement is as close as possible to dimension being measured. But that will make the measuring instrument more expensive as well. For as an example, go and no go gauge. Number 3, whenever possible, the measurement should be taken at 20 degrees centigrade of temperature. Measurement equipment must be carefully used and looked after. It must be cleaned before and after use. It should not be mixed with other bench tools and cutting tools. It should be kept in cases provided when not in use, and bright surfaces of such instruments should be protected with oil film or jelly. Measuring instruments should be inspected for errors and damages before use. The calibration chart of measuring instruments and equipment should be consulted. For checking whether the instrument is working right or not, for example, in the case of micrometer, the manufacturer supply a small cylindrical stick along with the micrometer. For example, if the micrometer measures from 0 to 25 mm, a small cylindrical stick is given along with the micrometer, which is having a length exactly as 25 mm. So when we take reading of this 25 mm stick in the micrometer, we come to know whether the condition of the instrument is all right or not. And accordingly, we may make some changes in the readings which we are taking. So for the micrometer, it's a very sensitive instrument, as you have all of you must be aware, and you must have seen this micrometer. So there's a ratchet provided on one end of the micrometer on the thimble side. So we are using this ratchet and we are rotating this ratchet so that the pressure created on the job is not very high, and so that the pitch of the screw does not change or alter or get damaged, the threads. And the last point is for taking right measurements, the maker's recommendation should be followed for maintenance and storage of the instrument. So the instrument should always be kept safe from dust, heat, and it should not catch rust. So some kind of oil film or jelly film should be provided on the instruments. The standard basic units of measurements Following are the basic units used for measurements. Due to the topic scope, we shall be discussing linear measurement units and standards only. So, in our engineering field, we need to know all the basic standards of measurements. For the case of length, we have the unit meter. For mass, we have kilogram. For time, we have second. For electric current, we have